So now you can go ahead. A ball strikes a wall, the left at a velocity of 60 meters per second, and rebounds at the same velocity. Then you are told to calculate the change in velocity. So we can have the solution. So the moment you are asked about the change in velocity, then change in v will be given by final velocity minus initial velocity, because we just want a change. So our final velocity will be 60, then we minus our initial velocity. If this is the wall, and then the body was moving towards the left, then it means that it was taking a negative value of velocity. So negative 60. Then this one is going to give you 60 plus 60, and this is 120 meters per second. And go to question 2, where you're told the diagram below shows a velocity time graph. Then you're told sketch and adjacent to it a displacement time graph for the same motion. So the first graph looks like this. Which is of velocity against time. It's like this. So this is the graph in question. Then now we are supposed to give a second graph, which is of displacement against time. So if you look at this one, the body was moving from a high speed. So this velocity over here. Then it was moving downwards. You can see we are coming to a velocity of maybe at 0. So what do we expect when it comes to displacement? The displacement is supposed to increase, and then it appears to be in a manner that there is no more change in displacement because the velocity has come to finally a resting place of 0. So if I draw a graph of this manner, then I must show that at these parts, then it is like there is no more change in displacement. So it's like it is flattening. Then that one will have got a solution for the question. So that is it. We can have our question 3. On the axis provided, sketch a velocity time graph of an object that is uniformly accelerated given that when t is equals to 0, then v is greater than 0. So we shall have the axis here. So this is velocity, and we have time. So we're supposed to give a solution for the same. So we are just told that the body is accelerating, meaning that we just need to have uh, just an increase in velocity against time. But we are given a condition that at time zero, then velocity is greater than zero. So you're going to pick any point as long as it is above the zero mark, and then you can have it like this. So that one we will have solved. The diagram below shows a tape produced by a tick timer with a frequency of 50 hertz. Calculates the acceleration of the object which was pulling the tape. So you're going to have 11 dots with an increasing spacing. So these are 11 dots with an increasing spacing. it is being pulled in this direction. Then you can have this portion labeled A. It is of distance 2 centimeters. Then we have another one here, which is B. And then it is of 4 centimeters. The question is demanded we calculate the acceleration. But before looking for the acceleration, then the first thing you need to get is the period. So period or time is given by 1 over f. It is 1 over 50. And this one will be the same as 0.02 seconds. This means that in between two dots, it's taking a period or time of 0.02 seconds. So now you can get initial velocity at A. So we know that this will be given by 2 centimeters divided by a period of 0.02 seconds. And this one will land us at 100 centimeters per second. We have our final velocity at B. Then I can say B will be given by 4 centimeters divided by 0.02. This one will be 200 centimeters per second. Then now the last portion, we'll be looking at acceleration will be given by V minus U over the total time taken. This is where we need to be very careful because getting this and this is with a lot of ease. But when it comes to the acceleration, then you can say our acceleration will be given by 200 minus 100 divided by t. Now you want to look at the t. Remember when you want to get total time taken for this one, then you must look at the places or the paths where you use to calculate the initial and the final velocity. So it's like you must get the average velocity. So you count the number of spaces because you must pick the midway of A and the midway of B. So you do away with this part and you do away with this part. But this space in here, where we have a small half, then we have 1, 2, 3, 4, 5, 6, 7, 8, and we are having a half. So we have 8 spaces plus 2 halves. And this gives you a total of 9 spaces. So the total time taken will be 9 times the period for one space. And these will give us 100 divided by 0.18, and this will land us to something that is 555, 567 meters per second. Thank you for having followed the previous working, and now you have understood. You can work it on your own. Thank you very much. I would like to pose another question that is demanding the same attention, but in this case, we shall be having a different way when it comes to the distances of calculating the initial and the final velocity. Therefore, call it question 5 now. Katika timer tape in the figure below shows the motion of a trolley in the direction shown. Find the acceleration of the trolley. If the frequency of the timer is 50 hertz. Is going to have 13 dots in an increasing specimen. So that is it now. And we are supposed to get the, the, the acceleration. In accordance with the direction that we have been shown that these ticker type or the tape was moving at, it was moving towards the right. So in this case, we expect it to uh, be decreasing, to be having a decreasing acceleration. And therefore, our initial velocity, then we shall use these parts. So we can call it to be maybe part Y. So the knots, the acceleration will be decreasing. Therefore, our initial velocity at Y will be 4 centimeters divided by, let's look at the number of space in here. 1, 2, 3, and each space is of 0.02. This is 4 divided by 0.06, and it will leave you at 66.67 centimeters per second. Now I can call this one to be at X. So now you can look at the final velocity. Excuse me. Final velocity at X. So we shall have a distance of 2 centimeters divided by, let's count the number of spacing. 1, 2, 3, 4, 5. So it will be 5 each of 0.02. This is 2 divided by 0.1, getting 20 meters, sorry, 20 centimeters, 20 centimeters per second. Now we have parallelogram when we are looking for the acceleration. Acceleration will be given by V minus U over T. So in this case, we shall be having our final velocity of 20 centimeters per second minus 66.67 divided by the total time taken. You pay some serious attention to these parts. Pay attention. For the left hand side, must get the midway of X. we get the midway of x. So we have 1, 2, 3, 4, 5, 6. So the center one, it will be the center part where we shall be using will be this part, like that. So from this part towards the right, we can use it. What about at point y? We shall get the midway of y, and you can see we are having 4 dots. So at the midway of these 4 dots, like that. So we said we do away with these parts, and we also do away with these parts, then use the one that has remained. So we shall count now the number of spaces. We have a half here. You have 1, 2, 3, 4, 5, 6, 7, and we have another half here. So we are having 7 plus 2 halves. This gives me a total of 8 spaces. So in this case, we shall have 8 spaces times 0.02. And after the computing, you are supposed to get a negative 291.9 centimeters per second. I think somebody can confirm that. Thank you. Now we can give a different version of the question so that we may not dwell on the same concept. You're told that an object is dropped from a height of 60 centimeters, 60 meters, sorry. At the same time, another body is projected upwards with a velocity of 20 meters per second. Determine the point, sorry, the time it takes for the two objects to meet. and the height from the ground in from the ground to where they meet. So now we can solve this one. You can just indicate the distance. So you're told our body is moving from up at a height of 60 meters. Then we have another one. So we have a falling body and another one that is moving from down towards up. And then at the same time, another object is projected upwards at a velocity of 20 meters per second. Then we are told determine the time it takes for the two objects to meet and also the point at which they meet. So we can assume they meet from the ground, above the ground, at a distance of x. So they meet somewhere here. So meaning that the one that is coming down, the remaining distance will be 60 minus x meters. So this is our object. So the one that is falling, so we can have some things here that we need to note. The body moving or the objects moving downwards as a positive g, while the projected upwards as negative g. In short, it is moving against gravitational pull. So the one that was moving up, it had an initial velocity of 20 meters per second, whereas this one, like it was coming from rest, So you can say its initial velocity was 0 meters per second. Now let's go ahead. So we can start with the projected body. So projected body. Its initial u, since we have said that it is moving against gravity, then we can award it negative 20 meters per second. So we can create an equation and say that when it is moving upwards, it will be covering a distance of x. So from the second equation, you can say that x will be given by ut minus half gt squared. So this one now will we substitute over here. We say x will be given by our 20 meters, this one, times the time that we don't know, minus half times 10 times t squared. And in this case, we're going to obtain our equation 1. So x will be the same as 20t minus 5t squared. This becomes our equation 1. The second body, which is dropped body, its initial velocity was at 0. So it covered a distance of 60 minus x, and therefore from ut supposed to be plus, sorry, plus half gt squared. So substituting these values, then we shall have 60 minus x is equals to 0 plus half times 10 times t squared. So 60 minus x will be 5t squared. Then this one becomes our equation 2. Let's do something over here. We equate equation 1 with equation, okay, kidogo tu. just a moment. We have a part that means a lot of mathematics over here. So we are having these two equations here. That is x is equals to 20t minus 5t squared. That is equation 1. And we have 60 minus x is equals to 5t squared. And that is our equation 2. So we substitute x in equation 2 using equation 1. So we shall say the part where we are having x, we substitute with the value of x from equation 1. So it will be 60 minus 20t minus 5t squared is equals to 5t squared. So, 20t. So from the opening here, there's something that I skipped. We had a negative value here, like that. So it now becomes 60 minus 20t plus 5t is equals to 5t squared. Hii ikienda namna hii itakuwa imeisha. So 60 is equals to 20t and my t becomes 60 out of 20. You get 3 seconds. Like that. Now we can get, since we have got the 3 seconds, now we can use the second equation to get the value of x. Maana ndio inaulizwa from the ground. So t, we have got that t is equals to 3 seconds. Now we want to find the height from the ground. So substitute t in the second equation. So we shall have 60 minus x is equals to 5 times t, which is 3 squared. So this one will be a value of 45. When it comes to this other side, it will be 60 minus 45. Then we shift this one to the other side. It becomes now x. So from this one, our distance or the height from the ground becomes 15 meters. Thank you so much. You can